Okay, class, today we're going to be talking about moles. So, first of all, what is a mole? A mole is a grouping unit, much like shoes are talked about in pairs, eggs are talked about in dozens. If you've got ordering lots of pencils, you can order a gross, which is 144. Or if you have one ream of paper, it's 500 sheets of paper. One mole is basically something that's just a lot bigger than that. It's 6.022 times 10 to the 23 of anything, okay? And it is called Avogadro's number in honor of the scientist who first discovered it, Amedeo Avogadro, in the 1500s. Okay, so, and here is just a little joke for you. Hey, I just met you, and this is crazy. But here's my number, so call me maybe. And that is Avogadro. Oh, Miss Berger, you're so clever. I actually just found it online. What do you get if you have Avogadro's number of donkeys? Molasses. Haha. Okay, so the mass of 1 mole of an element is equal to its mass on the periodic table. Okay. So this is called its atomic mass. All right, so if you have 39.10 grams of something, of potassium, you have 1 mole of potassium. Okay, so how would you count out a mole? Well, you don't, okay, because they're so small, the atoms are so small that you can't physically count them. So being able to convert between grams and atoms or molecules is actually really important in chemistry. And that's where dimensional analysis comes in. Okay, so if you know one out of these 3 units, mass, moles, or atoms, you can figure out the other. Okay, now I just advanced too much. So if you know one of those 3, you can figure out the others. Okay, so we're going to do some dimensional analysis together. So you can do calculations. You can do atom to mole calculations, mole to atom, gram to mole, mole to gram, and those are all one-step, easy peasy lemon squeezy kind of calculations. And atom to gram and gram to atom, those take 2-step calculations. They're still not that hard. Once you get the hang of it, it's not that difficult. You will need a calculator, scientific calculator, and you will need a periodic table for the rest of these notes. And I hope you did watch that video on how to use your calculator using, to use scientific notation with your calculator. Okay, so how many moles are in 1.739 times 10 to the 24 atoms of neon? Okay, so I know that in 1 mole of anything, there are 6.022 times 10 to the 23 things. Okay, 1 mole of anything is 6.022 times 10 to the 23 of those things. So I'm going to start by writing down what I know. I know 1.739 times 10 to the 24 atoms of neon. That's what I'm given. Okay, and as we've seen in the dimensional analysis, if we want a unit to cancel, it needs to go, if it's in the numerator, it needs to go into the denominator. Okay, so let's say I have like 4 times 5 over 3 times 5. 5 cancels because it's in the numerator and denominator. Okay. So now we're going to get rid of atoms. So the term atoms of neon needs to go in the bottom. And we want to get moles. So mole of neon goes up here. In 1 mole of neon, there are 6.022 times 10 to the 23 atoms of neon. Okay. So you're going to put this into your calculator, and I'm going to walk you through how to do it. You're going to type in 1.739 second comma, so E, you're going to get that capital letter E, no carets allowed, 24. And since 6.022 times 10 to the 23 is in the denominator, you're going to hit divide, divided by 6.022 second comma 23. And as you can see, the unit's atoms of neon has canceled out, and now my unit is moles of neon. Okay, and what we're going to do as far as the number of digits we're going to write down is we're going to use the same number of digits as what we started with. That is, we're going to use 4 digits, okay? So the answer, rounded answer I get is 2.888 moles of neon. Okay, next example. How many moles are in 3.011 times 10 to the 23 atoms of copper? Well, I'm going to start with what I'm given. 3.011 times 10 to the 23 atoms of copper. Okay, again, I want to get rid of atoms of copper and get moles of copper. So in 1 mole of copper, or 1 mole of anything, there are 6.022 times 10 to the 23 atoms of copper. So the unit atoms of copper cancels out, and our unit in the end would be moles of copper. Moles of copper. Okay, so when you put this in your calculator, 3.011 second comma, so that gets you that capital E, 23, divided by 6.022 second E, second comma, 23, you're going to get 0.5. But we want to make sure that we're providing the correct number of significant digits, the correct number of digits in our answer. This had 4, so I'm actually going to write my answer 0.5000. Those are the digits that are significant after the decimal. Moles of copper. Okay. Okay, so now we're going the other way. All right. Now we are going from moles to atoms. Okay. So we have 1.50 moles. And by the way, the abbreviation for moles is MOL. So if you want to save that letter E, the time it takes you to write a letter E, that is the official abbreviation. It's not a Y. Okay. If I have 1.50 moles of sodium, and I know that for every 1 mole of sodium, there are 6.022 times 10 to the 23 atoms of sodium. Okay, moles of sodium cancels out, and we're left with atoms of sodium. Okay, so put that in your calculator. I'll give you a second to get the answer. And our answer is 9.03 times 10 to the 23 atoms of sodium. Okay, now we've got 6.755 moles of lead. Notice nothing is changing about the way we're doing this based on what kind of atom it is or what kind of molecule it is. None of that changes. Okay, so starting with 6.755 moles of Pb, and for every 1 mole of Pb, there are 6.022 times 10 to the 23 atoms of Pb. Okay, so since this had 4 digits at the beginning, my answer should also have 4. What I get is 4.068 times 10 to the 24 atoms of lead, Pb. Okay. So we can go from atoms to moles and moles to atoms. So we can also go grams to moles and moles to grams. So 1 mole of any substance, of anything from the periodic table, is equal to its molar mass on the periodic table. Okay, if I have 4.50 times 10 to the 3 grams of oxygen. So of oxygen, this I'm going to say it's elemental oxygen, not oxygen gas. So 1 mole of oxygen is equal to its mass on the periodic table, which is 15.999 grams. So let's see how many moles we have of oxygen. Okay. Well, if I want to get rid of grams, I have to put it down here. Grams of oxygen and moles of oxygen. In 1 mole of oxygen, there are 15.999 grams of oxygen. Okay. So let's put this into our calculator. 4.50 times 10 to the 3. So second E3 grams of oxygen cancels out, divided by 15.999. Since this had 3 digits, we don't count the exponent as part of our digits. Okay, we're going to get 281 moles of oxygen. Okay, ooh, now we have 3.25 times 10 to the 5th grams of oxygen. Again, we have to get rid of grams of oxygen by putting it in the denominator and get moles of oxygen. In 1 mole of oxygen, it's 15.999 grams. Grams of oxygen cancels out. And we can have 3 digits, so we can make this 203 or 20,300 moles of oxygen. Okay. Moles to grams, same kind of thing. 1 mole of something is equal to its molar mass. So if I have 31 moles of aluminum, and I know that in 1 mole of aluminum, according to my periodic table, oh, I'm sorry, I put that in the wrong spot. In 1 mole of aluminum, there are 26.982 grams of aluminum. Moles of aluminum is going to cancel out, and I'm going to be left with grams. Okay, so we're going to round this to 2 digits because that's what we're starting with, and your answer is 840 grams of aluminum. Okay. We have 8.2 moles of carbon. In 1 mole of carbon, according to my periodic table, there are 12.011 grams of carbon. So moles of carbon cancels out, and we're left with grams of carbon. So it's 8.2 times 12.011. Okay, we're going to round that to 2 digits and get 98 grams of carbon. Okay, so what we've done so far are these one-step conversions. We're going from either mole to atoms and back, or we're going from moles to grams and back. Okay. But to go from atoms to grams or grams to atoms, we use our mole as our conversion factor. So I like to consider the mole as kind of like a layover. You have to go through the mole in order to get to one side or the other of the bridge, or one side or the other of the island. So if I want to go, from Groton to New London, I have to go over the Gold Star Bridge. There's no other way to get. Well, I guess I could go through Norwich, but you know what I'm saying. All right, so to go from atoms to grams. So I know I have a certain amount of atoms of SB, which is antimony. I can go from atoms to moles. Okay, and I can use my conversion factor, which is 6.022 times 10 to the 23. Okay. And then I know if I have moles of SB, I can get to grams of SB by using the molar mass. Okay, and the molar mass of SB is 121.757. So let's start with what we're given. We have 1.50 times 10 to the 23 atoms of antimony. Okay, got to get rid of atoms of antimony. So the term atoms of antimony has to go in the bottom. And the term moles of antimony, that's not an S, moles of SB. In 1 mole of SB, there are 6.022 times 10 to the 23 atoms of SB. If I was to stop this calculation here, my unit would be moles, but I want to make sure I keep it going so I don't lose any digits, okay? So now I have the term moles, and I want to go from moles of SB to grams of SB. So if moles is up here on the top, I have to put it down at the bottom. 1 mole of SB is equal to 121.757 grams of SB. Okay, so now my unit moles has canceled out. Okay, so what I'm going to put in my calculator, I'm going to tell you how I want it put into your calculator. So multiplication and division occur at the same step of PEMDAS, so it doesn't matter which you do first. So I always work left to right, like the way you read. Okay, so here what I would put in my calculator is 1.5 times 10 to the 23rd divided by, because this is my denominator down here, 6.022 times 10 to the 23. Then multiplying times 121.757. Okay, when you get an answer, my answer now is going to be rounded to my original number of digits. So that was 3 here. 30.3 grams of antimony. Okay. Let's go to the next problem. How many grams of F are there in 25 atoms of F? Wow, okay, so that's going to be a very small mass because there's only 25 atoms, and 1 mole is 6.022 times 10 to the 23 atoms. So we're going to expect a very small number of grams. Okay, so we have 25 atoms of F. We have to get rid of atoms of F. First, we have to go atoms to moles to grams. Okay, so get rid of atoms of F. Get moles of F. In 1 mole of F, there are 6.022 times 10 to the 23 atoms of F. And then in 1 mole of F, according to my periodic table, the mass is 18.998. Okay, so the term atoms cancels out. The term moles cancels out. And my unit would now be grams. So 25 divided by 6.022 times 10 to the 23rd times 18.998, because this is the numerator of my fraction and this is my denominator. Okay, so I get 7.9 times 10 to the negative 22 grams of F. Going the other way from grams to atoms, same kind of deal. If I have 5.40 grams of boron, I first have to go to moles of boron. Then to atoms of boron. Okay, so I know my conversion factor between grams and moles is going to be my molar mass. And my conversion factor between moles and atoms is going to be the 6.022 times 10 to the 23 number. Okey-dokes. So let's do it. The molar mass of boron, by the way, is 10.81 grams. All right, so we have 5.40 grams of boron. Now we have to get rid of grams and get moles, sorry. So get rid of grams, so that means if it's in the numerator, it has to go down here. Grams of boron goes down here. 1 mole of boron goes up here. And there are 10.81 grams of boron in 1 mole of boron. Okay, so now we have moles of boron. So now to get rid of moles of boron in 1 mole of boron, there are 6.022 times 10 to the 23 atoms of boron. Now I can get rid of moles of boron. There we go. Okay, so in our calculator, we're going to put 5.40 divided by 10.81, okay, times 6.022 times 10 to the 23. And our answer can have 3 digits. So we are going to get 3.01 times 10 to the 23rd atoms of boron. Okay. One more example, and then we're going to take things a little step farther. How many atoms are there in 0.02550 grams of platinum? Okay, so we have 0.02550 grams of platinum. To get rid of grams and get moles, so grams is going to go down here since it was in the numerator there. Grams of platinum, moles of platinum. In 1 mole of platinum, there are 195.08 grams of platinum. Okay, so grams of platinum cancels. We're left with moles of platinum. Well, in 1 mole of platinum, there are 6.022 times 10 to the 23 atoms of platinum. Now, in terms of significant digits, some of you may have learned it last year, some of you may not have. This one has 4 significant digits, but I am not going to be taking points away from you this year for significant digits. I would have taught you them had we had class face-to-face, but we don't have it right now. So just my answer is going to be rounded to 4 digits. Okay, and that is 7.872 times 10 to the 19 atoms of platinum. But guys, I know what you're thinking. You're thinking to yourself, hey self, what about molecules? She's been talking about atoms this whole time. Hey, I got you. All right? We can calculate the number of moles for molecules too. So molecules like water. Well, one mole of water molecules is equal to the molar mass of 2 hydrogens and 1 oxygen. Okay, so that's what we got to do. Each mole of water weighs 18.015 grams. And then we can just use that in our calculations. But if you're dealing with molecules, then you have to make sure that your unit is no longer atoms, but molecules. Okay, so first we're going to practice calculating molar mass. So we have 2 aluminums here, an aluminum oxide, and 3 oxygens. Okay. So each aluminum, based off the periodic table, is 26.982, and each oxygen is 15.999. Okay, so we get 53.964 grams and 47.997 grams. So the molar mass of this is 101.961 grams. Okay, for our friend magnesium phosphate, we have to remember that anything inside the parentheses is multiplied by what's on the outside of the parentheses. So we have 3 mg's, 2 p's, and 4 times 2, which is 8 O's. Okay, so we have 3 magnesiums times 24.305, 2 phosphoruses, which are 30.974, and 8 oxygens, which are 15.999. This gives me 72.915, 61.948, and 127.992, 262.855 grams. Okay? All right, so now we're doing mole calculations. So if you've got a mole of carbon, you have 6.022 times 10 to the 23 of these. If you have a mole of hydrogen gas, you have that many hydrogen molecules. Same thing with methanol. If you have that many molecules of methanol, you have it's all together. It doesn't get multiplied by the number of things that are part of it. Okay, so how many moles are in 35.45 grams of water? So we're going from grams to moles. So this is only a one-step conversion. Well, we already know, we did this, I actually showed you the calculation, that there are 18.015 grams in 1 mole of water. So if I have 35.45 grams of H2O, and I know that in 1 mole of H2O, there are 18.015 grams of H2O. Then my answer is 1.968 moles of H2O. How many molecules are in 3.8 moles of PbSO4? Okay, great news here, guys. You don't need to calculate a molar mass here because this is just a moles to molecules problem. So the molar mass never comes into here, so don't worry about calculating it. Because the conversion factor here is Avogadro's number. So if we have 3.8 moles of PbSO4, and I want to get rid of moles in 1 mole of PbSO4, there are 6.022 times 10 to the 23 molecules of PbSO4. Moles cancels out, and I'm left with molecules. And I'm going to get 2.3 times 10 to the 24 molecules of PbSO4. Okay. 76.5 grams of H2SO4. And just for fun, the mass of this, I'm going to give it to you already. It's 98.07 grams, because otherwise it's just this video is going to drag on very, very long. So we have to go from grams to moles to molecules. So let's find our conversion factors. From grams to moles, that's our molar mass. And from moles to molecules, that's 6.022 times 10 to the 23. So I'm going to start with what I'm given, 76.5 grams of H2SO4 sulfuric acid. I'm going to get rid of grams and get moles. So in 1 mole of sulfuric acid, notice that I'm labeling everything. Okay, I need you to do that too. Ooh. Okay, there are 98.07 grams of H2SO4. And then for every 1 mole of H2SO4. There are 6.022 times 10 to the 23 molecules of H2SO4. Okay, and the calculator goes 76.5 divided by 98.07. Okay, did that steps. Now my units moles. Now get rid of moles. Times 6.022 times 10 to the 23. You get as an answer 4.70 times 10 to the 23 molecules of H2SO4. Look at that. Okay. I got one more for you. We're going from molecules to grams. Okay. So we're going to go from molecules to moles and from moles to grams. Okay, the mass of MnO2, so manganese 4 oxide, is, I'll just give you that. So its molar mass is 86.936 grams. So we're starting with 2.24 times 10 to the 23 molecules MnO2. Now we have to get rid of molecules and get moles. So molecules needs to go in the bottom and moles goes up here. Moles MnO2, and there are 6.022 times 10 to the 23 molecules MnO2. So now my units, molecules, she gone, okay? Now I'm getting rid of moles in 1 mole of MnO2. There are 86.936 grams of MnO2. Okay, so now moles is gone. Okay, so 2.24 times 10 to the 23rd divided by 6.022 times 10 to the 23rd times 86.936. Okay, that's going to give me 32.3 grams of MnO2. Okay, and that's all she wrote. If you have any questions, send me an email.